Hello viewers, and welcome once again. We are still under logic, Christ Almighty God's Algebra. Today we are going to treat identity. We know that we have law of identity, we have identity. When you talk about law of identity, we are talking about when the two relations, they are not the same in syntax, but they are the same in semantics. Semantics are the same, but syntax are not the same. But when you talk about identity, you're talking about that syntax of the relations are the same, and also the semantics are the same. Let us start. Identity. That means P is equal to P. This is a typical example of identity. You will see that in this equation is a logical equivalent. You find out that P is equal to P, they have the same syntax and also the same value. That means the same semantics. That means whenever this P is true, also this P is true. That means P at the right answer of equation, whenever it is true, also, sorry, P at the left answer of equation, whenever it is true, also P at the right answer of equation is also true. Whenever P at the right answer of equation is false, also P at the left answer of equation is also false. You say that is what? They have the same semantics and the same syntax. So this is a typical example of identity, different from law of identity. Let's prove it that it is identity. Prove. Suppose P is equal to P. You find out that this equation is logical equivalent. We assume that this P is equal to P is true. And this equation is logical equivalent. Because whenever the left answer of the equation is true, also the right answer of the equation is also true. Whenever the equation is false, also the left answer of the equation is also false. You see, it's logical equivalent. Since it's logical equivalent, we can transform it to biconditional statement, and it will still return the logical equivalent. If and only if P, if and only if P. We find out that whenever the left equivalent is true, also the right equivalent is also true. In the same vein, whenever the right equivalent is false, also the equivalent is false. So if it this statement, the one person getting falsity always true, say that statement is tautology. Statement is tautology. Being justified by logical equivalent. Since this statement P, if and only if P is tautology, we can also transform it to conditional statement and it will still preserve tautology. That means if and only if P implies P. You find out that whenever assistant is true, the consequence is also true. So if this statement, that was negative positive, always truth. We say that it is tautology. Is tautology. Being justified by logical equivalent. By logical implication. Being justified by logical implication. Now, since P implies P is tautology, we can then deduce that P exists because P is proper implication of P. Since P exists, you say that P is logical implication of P. That means the antecedent is logical implication of the consequence. If and only if P is logical implication of P. Now, since P is logical implication of P is true, also this also should also be true. That means if and only if P is equal to P or P. We have now found out that, or let's use and connective. Let us make it to be connective statement. So this P is equal to P and the P. That means this logical implication P is equal to P and the P by law of idempotent. So it is true because whenever this P is true, also this P and P is also true. Whenever this P and P is false, also this P is also false. It's a logical equivalent. So it is true that P is equal to P and the P, being justified by law of idempotent. Being justified by law of idempotent. You can go to this side. If and only if P is equal to P and the P and bracket not P or P. We have this statement is equivalent to P and D is equivalent to P and D P and P and P is equal to P. So this P and P and bracket not P or P is equal to P. So it's still logical equivalent. Being justified by law of identity. Because whenever you add the homology with any term, same thing as that term in law of identity. That means being justified by law of identity. If and only if P is equal to. Now we are going to transform this not P or P to conditional statement. It is in the duty statement. We are going to transform it to conditional statement. That means we have P and P and bracket P upon P. We have now transform it to conditional statement. Being justified by first edge case law. Being justified by first edge case law. We are going to distribute this implication P between P and the P. That is, if and only if P is equal to P upon P and P upon P and the P. I've now distributed this implication P between P and the P, and is still equal to P. Is still equal to P because P implies P is tautology and P implies tautology. Well, tautology and tautology is tautology. So what tautology and with P is P, which is equal to the left side of equation, being justified by distribution of implication, by distribution of implication, being justified by distribution of implication. If and only if P is equal to, let us reverse this P implies P, that's P upon P, and this P upon P to conditional, to disjunctive statement. Why I'm going to reverse it to disjunctive statement is because of this P is being generated from disjunctive statement. So whenever I want to revise it, it's going to be in disjunctive statement. So we're going to have P or not P and bracket P or not P and P. Being justified by first etiquette law. By first etiquette law. Then if and only if P is equal to, you see that P or not P is equal to T, and P or not P is equal to T by law of, you bring down no, you bring and P by law of complement. P or not P is equal to T by law of complement. Go to this side. If and only if, then this P, T, and T is equal to T by law of identity whenever T is interpreting at that time. That means we have P is equal to T and the P. Being justified by law of identity. If and only if P is equal to whatever tautology is interpreted at that time. So T and P is equal to P, being justified by law of identity. By law of identity. We have now proved that P is equal to P. So we can't prove T, it can prove the converse, but it's tautology because the same process we are going to use to prove the converse because they are the same syntax and the same semantics. So we then conclude, therefore, Therefore, P is equal to P. We have now proved that P is equal to P is identity. Due to P is equal to P is identity, so we cannot prove the converse because to prove converse is tautology. Because P is equal to P is the same thing as P, and is P is equal to P. They are the same syntax and the same semantics. So at this juncture, we draw our curtain. Thank you, viewers.